Hello, and welcome to Texas RE's Reliability 201 series. My name is Blair Giffen, and I'm the manager of OMP Compliance Monitoring at Texas RE. In this presentation today, I will build on the foundation from the Reliability 101 series and focus on the risk elements identified by NERC, give some examples, and talk about implementation evidence that your organization can provide to prove compliance. But before we get started, Texas RE's antitrust admonition is on your screen. If you have any questions, please contact our general counsel. So as we build on the foundation that we set up in the 101 series, we're going to focus in on the Compliance Enforcement Authority's ability to audit the risk elements identified by the CMEP-IP. The CMEP-IP, the Compliance Monitoring Enforcement Program Implementation Plan, is the NERC document that comes out every year, which helps the ERO focus on those risk elements identified. Today, we're going to talk about strategy that your organization can use so that you can provision resources and maintain evidence to prove compliance. And we're going to focus on internal controls around those processes and procedures and how you can implement those processes and procedures to help your organization prove compliance. So as I said, the ERO Enterprise Compliance Monitoring and Enforcement Program, or CMEP-IP, identifies the risk elements that the Compliance Enforcement Authority should prioritize for oversight. Today we're focused on operations and planning risks. And the four at the bottom of this table, transmission planning and modeling, inverter-based resources, facility ratings, and extreme weather response, are four NERC CMEP-IP elements that Texas RE and compliance enforcement authorities are prioritizing for oversight. You may also hear me use IBRs, inverter-based resources. So the operations and planning high-risk elements, I've grouped them into three categories: transmission, planning, and modeling. And those are going to be the MOD standards and some PRC standards we're going to talk about today. Extreme weather response, this is going to be EOP 11 and EOP 12. And facility ratings, FAC 8. That's going to be the focus of your facility rating methodology, the determination of your most limiting elements. So first, let's talk about transmission planning and modeling and your modeling data and analysis. So each one of these, Mod 25, real and reactive power capability, the purpose of this standard requirement is to ensure planning models are accurately represent generator real and reactive power capability. Mod 26, verification of models and data. This standard requirement looks at generation excitation control systems, or in the case of IBRs, plant volt-var control function models, and ensure that they accurately represent real functional behavior. Mod 32, power system modeling analysis, looks at consistent modeling data requirements and reporting procedures to support planning cases and analysis. So collectively, the MOD family of standards are setting up the intended process to develop and verify accurate models to represent real life behavior on the grid. And as these models are tested and system studies are developed and maintained, the intent is that they represent the behavior of the actual equipment installed to the best extent possible. And as the Compliance Enforcement Authority, we're seeking to ensure that these models are accurately developed, tested, and then communicated to those who are responsible for the planning and operation of the bulk power system. So what can you as an entity do to help prove compliance with these standards? Specifically, these modeling standards, we're going to we're going to cover the compliance implementation. We always recommend focusing on the RSAWs, the Reliability Standard Audit Worksheets. These are going to contain guidance on how to help prove compliance and implementation of these standard requirements. Mod 25 is a GO only standard requirement, and you're going to show that you can that you verified capability and that you submit that evidence to your transmission planner. Mod 26 is between a generator owner and transmission planner, and we look to see if there were any written requests to provide any instructions or model data between the GO and the transmission planner. And Mod 32 is a standard requirement focused on transmission operators and transmission planners to jointly develop procedures for steady state, dynamic, and short circuit modeling. And in ERCOT, this is done in the various working groups. And finally, looking at evidence and internal controls, what are some things that you can do to ensure that you're compliant with these standard requirements? Well, your processes and procedures, your initial performance, if applicable, your design, evaluation, simulations, and study reports. So the Compliance Enforcement Authority will seek to establish that you have a process and the steps were followed within the required time frame. And so your internal controls should be focused on the validation and verification, which is peer review, and the criteria to determine acceptable models. The model testing reports, the date you submitted your evidence to your information to the transmission planner, and the date you submitted your information to ERCOT could all be evidence to prove compliance with these modeling standards. Some failure points that we've seen with the mod standards are a failure to develop a process and a failure to explain how to respond to requests for information. And tracking models is very important. If you have a third party working on your model development, is there a peer review before you submit it to your transmission planner? So a recommendation here is to consider developing a formal documented process for verifying models and data. And doing so will standardize the model review process and ensure that relevant personnel are aware of the process and timelines associated with this model verification. And here I have what a power control system model verification might look like. Specifically here, this is an IBR with a VoltVar controller, and the control model is configured to regulate at the point of interconnection at the bus voltage level. And that is the recommended place to monitor this, and both simulated and measured values, and those need to be at the same point, and that is the point of interconnection. So here we see that the simulations are confirming the values are sufficient to provide reactive power control to the system, and both the simulated and the measured are tracking the same. There's no deviation between what's modeled and what's being simulated. Similarly here, this is a frequency control, and this is represented with the frequency control flag enabled. Simulations will confirm, again, that the modeling is the same as the real world plant response. And we can see here that the plant's under frequency response matches its simulated, its tested values and the simulated values, the same as the real world performance. Another transmission planning and modeling standard requirement is for focus of these protection and control system standards So here we have PRC 24 frequency and voltage settings, and this standard requirement's purpose is to ensure that generation resources remain connected during frequency and voltage excursions. PRC 27, coordination of protection systems. The purpose of this standard requirement is to maintain coordination of protection systems to detect and isolate faults so that those protection systems operate in the intended sequence. And PRC 5, Protection System Maintenance Program, PSMP, is to document and implement programs for the maintenance of all protection systems, automatic reclosing, and sudden pressure relays so that those are kept in proper working order. Frequency and voltage protection system settings are the generator owner's responsibility. And the generator owner needs to develop these settings with keeping in mind the known limitations of the equipment that it's protecting, and provide those settings when requested. So ride-through versus protection settings. This is an important concept to keep in mind when you're looking at protection systems. So ride-through means that you're able to stay connected during defined frequency and voltage events. Specific voltage and frequency capabilities and the ability to operate inside the no trip zone, which is now being called, outside of that zone is now being called the may trip zone. So you can trip in the may trip zone, but you need to stay connected and ride through in the no trip zone. So this is PRC 5, Protection and Control Maintenance, or PSMP. So if you have an operation or a misoperation on your system, you should determine whether your protection system component operated in the intended sequence. And if you determine that you have a misoperation, you should be developing a CAP, a corrective action plan, and that CAP should have a timeline associated with it for resolving the misoperation, the failure mode on the misoperation, and you should be evaluating other protection systems to determine applicability. In your protection system maintenance program, or PSMP, the intent is to identify your equipment for maintenance, whether it be time-based or performance-based, and ensure that the maintenance activities are kept based on the timelines determined in your plan, in your program, and that records are kept to prove compliance with the standard requirement for PSMP. So compliance implementation, again, recommending here, follow the RSAW, the Reliability Standard Audit Worksheet, and that will help you explain how evidence and documentation that you're keeping will sufficiently show implementation of the different protection system standard requirements. So I'm going to focus here on the PSMP, the Protection System Maintenance Program, because there are several failure modes associated with this program. One thing you should focus on is establishing the maintenance method that you're using, whether it be time-based or performance-based, and keeping documentation on the actual maintenance activities that are being performed. And you want to ensure that you're including all protection systems, automatic reclosing, and sudden pressure relays within your protection system maintenance program. And if you're using a performance-based interval, you want to ensure that you are maintaining technical justification around your intervals for your performance-based equipment. And one more element to this is monitored versus unmonitored you need to consider. And these are all laid out in your protection system maintenance program tables that come out of the standard requirement. And so we really encourage everyone to develop these processes and procedures around, develop that program, and ensure that the program is reviewed periodically. That's going to be your internal control. And if anything changes, do you need to update your program to ensure that your program is updated accordingly? So the other CMAP IP risk area is emergency operations and extreme weather response. And here we see EOP 11, mitigating operating emergencies, and EOP 12, extreme cold weather. And these two were identified in the NERC CMAP IP, and we're really looking to help entities build processes and procedures and emergency response activities around all emergency operations, including extreme cold weather. An area of focus with extreme weather is extreme cold weather. And in EOP 12, the requirement states that you shall have a cold weather preparation plan, which includes facility minimum operating temperatures, extreme cold weather temperature calculation, and this includes some guidance on the data and documentation used to calculate that extreme cold weather temperature. And the plan should include the capability and availability of that specific unit, annual inspection and maintenance of freeze protection measures, and the implementation of freeze protection measures around your generator cold weather critical components. So these are some new definitions, and I'm going to repeat these definitions again here shortly, but extreme cold weather temperature and generator cold weather critical components are both defined NERC terms. So when you have your extreme cold weather plan, one of the requirements in the EOP 12 standard states that you should train annually on that plan. And the personnel that you train on the plan are the personnel identified as responsible for implementing that plan. And the training materials should be unit specific. And one of the internal controls and feedback loops should include lessons learned. So if you have an event and they have lessons learned from that event, as the Compliance Enforcement Authority, we are looking to ensure that those lessons learned are implemented back into your plan and into your training. One of the things at Texas RE we're currently doing are walkdowns and inspections for cold weather preparedness. And this is something that should be included in your plan and in your training. Ensuring that implementation of freeze protection measures are in place. Those include heaters, windbreaks, heat trace, anti-icing, and instrument air. And if your facility has any fuel switching capabilities, that's something that your plant should note. And if you're going to be implementing any of those fuel switching capabilities during a cold weather event, then that should be included in your training and in your documentation as well. So as I said, Texas RE is actually going on site and performing walkdowns and checking things like heat trace, instrument air, and other low water drains that would be included in entity inspection checklists as well. So compliance implementation, again, RSAW, a lot of good information here. Please look into that to help explain, how you can ensure that your documentation is sufficiently showing the implementation of the standard requirement language, have your processes and procedures, specifically your cold weather plan. And again, we're going to ask you who is responsible for implementing this cold weather plan. Those are the individuals you should be training and have training documentation for. Evidence would also include training materials. And again, those training materials should be unit specific. So a generic training program may not be sufficient to help prove compliance with the training component of EOP 12. We're looking for unit specific training. What are the internal controls around some of this? As I said, walkdowns, checklists, change management, and lessons learned. So if something in your facility changes, how is that going to affect your cold weather plan? How is that going to affect your training program? And your walk downs and your checklists can also generate lessons learned and that feedback to your plan and your training. More internal controls around extreme cold weather plans and training. So after the extreme cold weather event, document those lessons learned and train on them as needed. Review the plan periodically and update accordingly. This should be done annually at a minimum. And use task management systems to track work and tasks associated with your lessons learned, your cold weather plans, and your tasks to winterize and follow up on winterization, freeze protection measures. So some best practices here around extreme cold weather plans and training. If you have a third-party contractor come in, review their work. If you're not working side by side with that third-party contractor, definitely have a internal control in place to check their work, whether it be spot check certain things that they did, sign off on those, document those things, have contingency plans. If a contractor is not available to do something for you in an emergency situation, what else? What are your plans what are your backup plans for that? Monitoring cold weather critical components. A best practice here is if you have a checklist and you're doing periodic walkdowns and you know a cold weather event is approaching or incoming, go ahead and increase those checklist walkdowns on your cold weather critical components. If you're in the middle of an event, maybe that increases your checks even more. And here, the last best practice here is verify that the QEESY is updated with your information. If you're going to have a derate during a cold weather event, let your QEESY know, your QSE, and they will in turn notify ERCOT in the ERCOT region. The QEESY is the one responsible for doing that, so they need to be updated with all generation rating information during cold weather events. So the third and final CMAP IP risk area of focus is facility ratings, FAC 8. So facility ratings used in the planning and operation of the bulk electric system. And the intent here is to identify your most limiting applicable equipment rating of the facility. So this is the facility rating methodology and worksheet are the two elements that comprise a facility rating of compliance evidence of compliance implementation with FAC 8. And we're going to talk about some themes that we've seen around facility ratings. So just a lack of awareness, a lack of not understanding how your methodology is laid out to determine your equipment ratings and your most limiting element. Inadequate asset and data management, meaning if you have a change of equipment on your system, what is your internal controls and your change management process around updating your worksheets and looking for that impact to your equipment ratings and your most limiting element? And again, change management, again, if you have something change, how is that feeding back into your process, into your worksheets? And then inconsistent development and application of facility ratings. So this goes to your methodology. There are a few options to use within your methodology. For example, engineering, best engineering judgment on your on the development of those facility ratings. That's the typical one we see. but the application of that engineering methodology on the different facilities in different locations or even within the same station is a failure mode that we've seen, and we'll talk about best ways to help mitigate that. Okay, so compliance implementation, again, RSAWs, use your worksheets, and this will help you explain how the documentation will show implementation of both your methodology and your worksheet. Have that process and those procedures updated and reviewed often, if not, at a minimum annually. Your methodology should be updated, and your facility rating changes to your workbooks should be reviewed and peer reviewed. The intent of this workbook is to identify your most limiting element, and that most limiting element is being communicated to your transmission planners, to your transmission operators, and to your planning coordinators. And in ERCOT, these are determining your security operating limits and your IROLs as well. And so if we have an incorrect MLE identified, we're going to have incorrect operational limitations, which could impact system operations adversely and lead to either a line inadvertently tripping or not using the capacity of that facility to its design, to its most capable. So that's the importance of having these correct facility ratings and ensuring that your most limiting element is correct. And I will say also, identifying your second most limiting element is a best practice here. Finally, internal controls around this methodology and workbook, periodic reviews and facility walkdowns. Texas RE is also performing facility rating walkdowns. So what that means is we may come to one of your facilities with binoculars and verify that what is in the field can be confirmed within your workbook. And that will be, so we'll be looking at all of the facilities, all of the elements identified in your facility, their associated ratings, and then verifying in your workbook that those ratings are correct. Change management. If something changes in your station, that could affect your most limiting element. Therefore, you need to have a process in place, internal controls in place to ensure that that change makes it into your workbook. So I'm going to wrap it up here with a summary here. As we stated, the NERC CMAP IP, the Compliance Monitoring Enforcement Program implementation plan, identified several areas of risk for the Compliance Enforcement Authority to focus on, including transmission planning and modeling, specifically modeling and protection systems, and inverter-based resources are a focus through each one of these risk elements as well. And extreme weather response, the two definitions I mentioned, extreme cold weather temperature, the data associated with calculating that extreme cold weather temperature, documenting your process for making that calculation and where you're getting your data from is important. Freeze protection measures for generator cold weather critical components. And the generator cold weather reliability event is another NERC-defined term in the glossary of terms associated with EOP 12. So facility ratings have a methodology. Have your methodology describe how you're going to determine your facility ratings and your most limiting element. And then your workbook or your worksheet that you use to document those facility ratings, important piece of evidence that you need to maintain. And I always identify that most limiting element. What is the most limiting element that that's going to be communicated out for planning and operational purposes? So that's everything. Please, if you have any questions or comments, you can reach out to us here, compliance@texasre.org. So thank you for going through this with me today, and I will see you on the next one.